let's take a moment and see what we got in terms of questions. Amy? Oh, okay. Yeah, go ahead. Okay. So number 2 on homework 6. So Amy, you'll help me out with this a little bit and tell me which variable did you try to cancel out first? Z?
Yeah.
Great. And what did you do to do that? B plus 2C. Okay. Good. And what else? Yep. Good. All right, so let's do that. So I'll just recopy B. And then 2C. Okay. And then A plus C, there's nothing to rewrite, so I'm just going to add those two together just right from where they're at. Does that look okay to there, Amy? Okay. So if we put those together, we have this. And at this point, you might be able to see already that this has infinitely many solutions. You might see that equation E is 3 times, or multiply equation E by 3 times gives us D. If you didn't, that's okay. You could have done like 3 times, or negative 3 times E plus D. If you do that, it gives you 0 equals 0. So whether you did that or whether you just made the observation and noticed it was infinitely many solutions and then continued on, either is okay. Let's come up with that parametric solution now. So to do that, we're going to use one of these two equations, D or E. I would pick the one with the smaller coefficients. And then let's get either the X or the Y by itself. It doesn't really matter. Do you have a preference here, Amy? Did you try doing one or the other? You think you got the Y by itself? Okay. So if we do that, we would have added the X over and then divided by a negative 12. Oops. So we would have gotten that, right? So that's going to give us two parts to our answer. So we know that the y is negative 11 over 12x plus 1/2. And because that answer is written in terms of x's, x is going to be my parameter. So that's just x. And then to find my z, I'm going to just plug in that value for y into either equation A, B, or C. So it doesn't really matter. Let's plug it into B because that looks like it has the smallest coefficients all around. Is that okay? Right. So that's, I have negative 5x minus 2 times negative 11 over 12x plus 1/2 as 4z is equal to 20. I think I probably should have written that somewhere else because I need more space than what I have there. Oops. Oh my goodness. So distribute the negative 2 through. That's going to give me negative 11 over 6x plus, oops, sorry, should that be plus 11 over 6x minus 1 minus 4z equals 20. Okay there? Then we'll add the 1 over and then combine the 11/6 and negative 5. So if making a common denominator, negative 5 becomes negative 30 over 6. So that becomes negative 19 over 6x minus 4z is equal to 21 now when I added the 1 over. Is that okay? And then we'll add over the 19 over 6x. And then multiply by negative 1/4, which is the same thing as dividing by negative 4. And that should be our answer then. Does that feel okay? Good. Edmund?
I just want to clarify, like, if we decide to eliminate different variables like x or z, we would get different things.
Yes. Yes.
Okay. And then flip.
Okay.
So you do 5 for the left.
This one right here that we're looking at, number 5? Okay, sure. Before I do that, Mackenzie, did you have as a, okay. I didn't know if it was a separate question or related to the one we were working on. Before I moved on, I figured I should double check. Okay. So, Edmund, what variable did you choose to eliminate here? Okay. Negative 4a plus b. Okay. So if I do a plus c, I get 0 equals 1, right? I'm done. There's nothing more to do because that's my indicator that it's no solution. That's it. It's over. Good.
Yeah, I also got z is equal to negative 1/7.
Oh, you're trying to make it work?
How am I going to put a variable in?
Yeah. So if you get a contradiction like that at any point, whether it's on the first elimination, the second elimination, the third elimination, that's our indicator that there's no solution. Sometimes it happens right away, and that's nice, because that's the least amount of work possible. But sometimes it's inconvenient. If you picked a different variable, you might have had to do, might have had to wait to the third elimination before you found it. Sergio? That's where they're at right now. They should be.
Oh, I didn't scroll. I see.
That's okay. Yep. I have an error message happening on my sync right now, so it's telling me. I don't know if that's an error for I can't see all of yours, or if it's my stuff not coming in. So if you couldn't see it also, that would be one of the reasons why. But it will get there eventually.
Yeah, I think that's me.
Yeah. Okay. Mackenzie? Okay. Amy, was that going to be the... Okay. Sure. Again, I didn't want to move on in case we're still needed to talk about 5 there before I gave everybody a chance to ask about it. Okay there, Big Mac. Which variable are we going to eliminate? X's. All right. And how do you want to do that?
A plus negative B plus negative 2.
Right. I knew where you were going once you said the negative 2. All right. So I'll recopy this just because we did change some signs. So I guess there's no reason that I can't. And then I do the other one. What did we do here? B. So recopy my B. And then negative 2 times C. Okay, so at this stage, you're probably like, oof, what do I do with this, right? Okay. Did anybody get something different if you had chosen? Did anybody choose to eliminate something other than X's here when they did this? Because I think you would have gotten a different result had you picked a different thing to eliminate. I think if you done Z's, it would have been a little less inconvenient. Or maybe if you picked a different pair of equations. But you didn't have to get y equals 6 as your first result here. But it's okay that you did. So let's pretend we didn't do anything different. And show you how to resolve that. So this is all we know right now, right? We have some answer, and we know the answer for the y part is 6. So what am I going to do? Well, I'm going to make a 3-variable, or I'm going to make a pair of 2-variable equations by plugging 6 into the y spot to one of these 3-variable ones. Now, I'm not going to use the same pairs I used before. Hopefully, but so this is going to become a 12 here. So when I subtract it over, that's going to become negative 14. This would become an 18 here. So when I subtract that over, that's going to become negative 14. And that's going to become a 6 here. So when I subtract that over, I get negative 7. Is that okay? And now right away, we can tell that there's infinitely many solutions here. Because we have these 2 equations are exactly the same. And this equation is clearly a multiple of the other, or the other 2 are clearly a multiple of that one. So no matter which 2 equations you pick, it's an infinitely many solution situation. Is that cool? Okay. So let's pick one of these equations. I'm going to pick this last one and isolate one of the 2 variables, either x or z. It doesn't really matter. For the sake of argument, let's go with the x. So I have negative 7 minus z. And the z is my independent variable. And I'm done. So this one's a little different in that every one of our answers, the y-coordinate is 6, but that's okay. All that tells us is that, like, if you think about this as like a three-dimensional situation, you know, where like you have, you know, like an x, y, and z axis, is that this solution is a line that's parallel to the y-axis. No, it's parallel to one of the axes where the y-coordinate is all the same. You know what I mean? Like if you have a two-dimensional, if you have like a horizontal line, all the y-coordinates are the same. Right? If you translate that into a horizontal line in 3 dimensions, all the y-coordinates can still be the same. That's kind of what's going on. That can happen, so it's not, you shouldn't be, don't freak out if it does. Amy? So all I did was I took my answer of y equals 6 and I plugged it in and then moved that over to the other side. So like in equation A, 2 times 6 is 12, and I subtracted 12 from both sides to get the negative 14. Is that cool? And then equation B, 3 times 6 is negative 8, or is 18, and I subtracted 18 from both sides. Again, that gave me the negative 14. And so on. Does that feel okay? Sergio?
Why can't you solve this because it's different variables?
Well, because we've written our answer for x in terms of z. So z is acting like our independent variable. That's like our parameter. So because we have infinitely many choices that we can pick for z, that gives us our infinitely many x's, and the y is always 6 in this case. Maya, did I see your hand up also? Sure. I'm sorry that I moved on before you got a chance to ask about it. You should have interrupted me. Next time, try to interrupt. You don't have to wait. So you got a positive 11 over 12 for the y. Did I make a mistake or did you make a mistake? Did you have this negative 11 minus 12y equals negative 6? Okay. So we added 11x over, right? And then we divide by negative 12. So I think it should be negative 11 over 12. Is that okay? Okay. Yeah, good. I'm glad. Again, I don't mind double checking, right? Like I make mistakes. You guys have seen me do it a bunch of times already. It's okay. If we need to double check something, if you're like, "Ooh, I'm not sure he did that right," please don't. I'm not gonna go crazy about that. Like I'm humble enough to know that like this is exactly the kind of mistake that I make is I get going too fast and I drop a negative sign. So like perfectly reasonable thing to come back and want to look at. Cool. Okay. Yes, Loretta. Sure. Okay, so Loretta, what did you try to eliminate first? X? Okay, and how did you do that? Okay.
-12 and 21
Okay. So you need to do two separate pairs. You can't do all three of them at once. So are you saying that we're doing this then? Okay. Just keep in mind that you could have just done like a minus 3 times b, and you could have done negative 4b plus c, and the numbers will be a little bit smaller for you. And that usually helps out a little bit, but what we've done here is not incorrect. Okay, so 4 times 3, 4 times 3, 4 times 4, and 4 times 23, and then 12 times 1, 12 times 2, 12 times 3, 12 times 25, ugh. All right, then this is all the same. 12 times b we just did. And then 3 times c, so 3 times 4, 3 times 1, 3 times 1, 3 times 25. Okay, so that's 12y minus 20z equals 208. And then 21y minus 33z is equal to 375. Loretta, are you okay so far, so good? Okay. So those are going to become my new system. And which variable did you try to eliminate now, the y or z? Okay. And how did you do that? Okay. One of them should have been negative, though, correct? Which one? Okay. So negative 21 times d plus 12 times e. Ay caramba, it's calculator time for me. I am too tired to try to do 12 times 21 in my head. That's kind of sad, but that's where I'm at today. You know, guys? 21 times 20 is 420. And then 21 times 208, yuckarooski, I'm doing that in the calculator, 4368. And then 21 times 12 is 252. 12 times 33, 396. And then 12 times 375 is 4,500. So what do we got here? That's 16z equals 8868. Yeah. Oh. Yeah, good catch. Right, that's what you're saying? Thank you. I was just looking at the result and going, that doesn't look right. That still doesn't look right. Okay, plus 420, yes. Maya, you're a lifesaver today. Thank you. There we go. Is that right now? Because I get not an integer. I thought all these answers were supposed to be whole numbers. Oh, Loretta, what did I do? Maya saved us halfway here. Before I go and finish this off, let's just, oh boy. Okay. This apparently was supposed to be no solution, so that's really bad that I got that. Where did we make our mistake? Who sees it? I'm listening. Go ahead. There's no bad ideas here. Okay. I'm still searching, Loretta. That, okay. 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 Come on, everybody, help me find this. Ah! I see it now. Great googly moogly. Anybody else see it? So there's my equation for B. When I multiplied it by negative 12, that should be negative 24. That should be positive 36. And that should be negative 300. Right? Oh, and it had to be the one that I used in both of them, right? How frustrating. Let's try it again. Ay, ay, ay. Did anybody see any arithmetic errors that I made there before I go on to the next step here? Okay. Here's a fun question. Does anybody see the number that both 36 and 27 go into? other than 36 times 27, that would work, but oh, there's a 9 in both of them, but they don't both divide 9, right? We want to find the least common multiple of those two numbers, not the divisor. It's 108, which is 9 times 12, because the first one is 9 times 4 and the second is 9 times 3. So the least common multiple should be 9 times 3 times 4, or 9 times 12. So we'll do negative 3 times D plus 4 times E. Not that you had to use those ones, but they're going to make things smaller for us, or keep things relatively smaller, so that this doesn't get any more unwieldy than it needs to. Four times 39. Yes! Now we're cooking with gas. Loretta, we did it. We just had to make a mess out of it first. Is that okay? Yeah, I made a bunch of them along the way also. It's amazing how, like, when you do it by yourself, you can do like 20 of these without making any mistakes, but as soon as you try to do it the way that someone else would do it, it's like, I just make mistake after mistake. Oh, it's nothing to do but laugh at yourself, right? All right. Sorry about making a mess out of that, Loretta. But it's a good exercise, right? In terms of, like, what do I do if this isn't working out the way it's supposed to? You just got to go back and look for your mistake. It's usually something dumb. At least that's the way it is for me. I make dumb mistakes like it's going out of style. Like forgetting to multiply by a negative halfway through the problem. Okay. Last call on questions from the homeworks. Cool. So let's start talking about the plan for today. So the next section we're going to talk about is writing and solving story problems. So these are all problems that involve systems. So this is homework 4. We're just going to do a couple of the problems from homework 4 as an example. Okay. So let's zoom in there so we can read. So I think we'll do like 1, 2, and like 12 or something, I think was what I decided when I read through this. So 1 says, the school that Lisa goes to is selling raffle tickets to the annual, just selling tickets to the annual talent show. On the first day of ticket sales, the school sold 4 senior citizen tickets and 5 student tickets for a total of $102. The school took in 126 on the second day by selling 7 senior citizen tickets and 5 student tickets. What is the price each of 1 senior citizen ticket and 1 student ticket? This is not going to be a well-attended talent show, it appears, as they're selling single-digit numbers of tickets here. But, you know, maybe if there's no talent, it won't be that bad. It won't be that big. It won't be a bad thing that nobody came, right? Okay. So jokes aside, since nobody even smiled at that, I couldn't tell if you're smiling because you're wearing masks, but I'll assume you didn't. Let's create a variable name to represent these 2 quantities that it's asking for, since it's clearly asking for 2 quantities, right? So I'm going to use X to be the dollars per senior citizen ticket, and Y to be the price of the student ticket. Typically, I like to pick a more intuitive variable name, but since one is senior citizen and the other is student, they both start with the same letter. I mean, it seems like a dumb idea to do one as S and the other's capital S. I would get confused halfway through. So I just went with the good old X and Y. Everybody okay there? So upon reading this, hopefully it was pretty clear that each day is going to be its own separate situation, right? So what equation can we write that describes the first day? Joe? Great. So 4 times the cost of the senior citizen ticket plus 5 times the cost of the student ticket should give us the total amount of money we brought in for that very first day. Makes good sense to me. Everybody agree with that? Okay. And day 2 is probably going to be our second equation, right? What would be the equation we write there? Great. So there's our system. I'm not going to worry about solving it right now because you guys will solve them in your homework. But the thing that's a new skill is writing the equations from the words. That's the part that I want to worry about in the notes. I'll leave the solving to you guys. Is that okay? Okay. So you do need to solve them, right? I just don't feel like doing it. Because I just solved a bunch of 3 variable systems and got half of them wrong and I'm feeling a little disheartened. I can get half of them wrong, but I made enough mistakes in there that, I don't feel good about myself. Okay, number 2. Flying with the wind, a plane went 183 kilometers per hour. Flying into the same wind, the plane only went 114 kilometers per hour. Find the speed of the plane in still air and the speed of the wind. So we need 2 things to solve for, right? It's asking for the speed of the plane and the speed of the wind. So I'm going to use P and W for my variables there. That's a little bit more intuitive. But you could use X and Y. It doesn't really matter. I don't care what names you give the variable. You can call them taco and hamburger if you wanted to, and draw a little picture of a taco and a hamburger if you wanted. Just a symbol. I don't know if you really want to spend that much time drawing the variables artistically on your math homework, but, maybe you like art, and you're like, I want to draw tacos today. That's fine. Anyways, before we start writing the equation here, we should probably talk intuitively with what it means when flying with the wind and flying into the wind. What does that mean if you're flying with the wind? Doritos.
That's like the wind behind you instead of helping you go forward.
Good. So the wind is behind you, like helping you go forward. It's like pushing. And if you're flying into the wind, it's going to be going slower because the wind is like pushing you backwards, right? Everybody agree with that? Okay. So how would we write the equation for flying with the wind? Okay, so if I was going 100 miles an hour and the wind was blowing 20 miles an hour, what would I expect my new speed to be? If I was flying with the wind? 120, right? How did you get that? Added the 2. So what should my equation be here? Yep. Everybody's okay with that? So what's going to be the equation for against the wind or into the wind? Very good. There's our system. Cool? So again, maybe you had to think a little bit about like what that means physically, but we got there, right, without too hard of a strain. All right, let's do one more here from the end. I don't think they really got significantly more difficult. I don't have page 2, though. I only took page 1. Said shrink. Uh, 12 will do. Yellowstone National Park is a popular field trip destination. This year, the senior class at High School A and the senior class at High School B both planned trips there. The senior class at High School A rented and filled 7 vans and 10 buses with 332 students. High School B rented and filled 4 vans and 15 buses with 459 students. Each van and each bus carried the same number of students. Find the number of students in each van and in each bus. Okay, so 2 variables. I'll use V for the students per van and B for the students per bus. Everybody okay with that? So on the tremendously originally named High School A, what equation can we write? Anybody want to give it a stab? Yeah, Jack. Yup. And then what about our second equation then? Great. Okay here? Okay. So that's all you really need to do for homework for it. Well, you need to solve the systems too, but 2 variable systems at this point should feel pretty easy. Sergio?
We're not going to do this for
Well, we're going to have to do this for harder situations than this. This is just our starting point. So that's what's on the docket for next time. But this is just the starting point, which hopefully feels pretty straightforward, right? So the next step is to introduce a really, let's say, real world applicable situation, and a very I should say potentially, depending on how nerdy we are, interesting situation that has a lot of real world relevancy. So there's a whole branch of mathematics involved with this kind of a problem that we'll talk about, where we have to do a little bit of this. But there could be lots of variables in those. But they're still not beyond your capability of setting up. We're not going to solve any of them because it's beyond the scope of this class to do the solving. Actually, we'll solve simple situations where there's no words. And then the word ones we'll just set up and not do the solving. Because if there's too many variables, there's too many dimensions, and we can't draw a picture to solve it. Because you need tools that we don't have to do the method to solve it. Okay. What I need for you guys to do now is if you take out your tablets and you locate the content library. In one moment, you'll see at the end of the content library something called Homework Quiz 3. If that hasn't shown up for you right now while you're looking, I've just synced. So if you sync again here in a minute, it should pop in. So you'll copy and paste this page into your own notebook, answer these questions in OneNote, and then upload that into the PowerSchool Dropbox for this assignment. Well, it says it's syncing right now on my end. I'll force a sync again. Just give it a second. It should be coming through. The content library on my page. And we'll do this one. Let's do that. It says it's working on it right now. It's now popped in for you? Okay. Good. I'm glad to hear that it did eventually come through. I just cleared my cache on my OneNote because it was chewing up too much space on my hard drive. So when it does the sync, it has a lot of work to do. So it's maybe not surprising to me that it took a couple of minutes to get it pushed up to you guys. Yeah. If you do, just take a picture with your cell phone and then email it to yourself and drop that picture into OneNote and then publish it as a PDF and turn it in. You can do that if you want. Does that sound fair to you? Good, I thought so too. And just one other added tip here. The answers for these should be whole numbers. So just to give you a little hint or a tip for checking purposes, your answers should be whole numbers. Let me just real quick double check that before I have to eat my words on that. I wrote these earlier with that intention, but I didn't double check them to make sure I actually didn't do a Mr. Kulik and goof up a negative sign or something and make a mess out of this. But I'll check that real quick just to make sure. Nope, they're good as advertised. That's a relief, And again, just as a heads up, when you move this over as a OneNote or whatever, you should be able to put your finger in there and press enter a bunch of times if you need to make more space for yourself. Like if you just and then press enter, you can move the problems up and down so you can make a lot of space for yourself if that helps. Some of us write bigger than others, How many of you guys are excited for not having to go go to the school on Thursday and Friday?
I'm so excited.
Mackenzie, that's you? You're ready for a break? Yeah.
Between football and school. Wow.
Yeah, I bet. Oh my gosh. Oh. I can't stop yawning today, guys.